Okay, hello and welcome to our talk. I'm Stefan Lattner,
And I'm Cyrano Wammer.
and we are colleagues and researchers at Sony CSL in Paris. So the title of our talk is "The Sound of AI: How Machine Learning Impacts Music Production." And we are aware that this is quite a brave title. What's the sound of AI? But we attempt to give some answers, at least what we can see from our current perspective. We won't be able to give definite answers to these questions, but we will at least point out some trends and some developments we already see and we are participating in. Yeah, and may I ask you to use headphones if you have them available, because there are lots of audio examples in this talk, and it would be really a pity if you couldn't hear them properly. So the overview will quickly tell who we are and what Sony CSL is doing. And then we will ask how will AI impact music production. We will give a very short historical context. We will point out some trends we can observe already. And then we will show some examples of AI-based music production tools, mainly from Sony CSL. And in the end, we will give you some clues, and we will talk about the experiences we've made in our work at Sony CSL so far, and also about technical limitations we are facing when we create AI tools for music production.
Okay, so I'll start by presenting the lab. So Sony CSL is a fundamental research lab. We're established both in Japan and France. Um, we have quite different activities. In Japan, the philosophy is more project-based. And in France, we are organized as teams working in common on some projects. So we're part of the music and AI team. Um, this team is made of researchers, developers, people in charge of the communication. We're all passionate about music. Most of us are musicians. And so we really like to do research in music. We research on common project with other teams in Paris and with the music related teams in Japan. And recently, we've also further developed our collaborations with the music industry. So, collaboration with Sony Music artists, Sony ATV artists, and also with Sony Interactive Entertainment and PlayStation to see how we can help from the music point of view in their activities. So basically, we're organized as shown here. We have research activities divided in three categories: audio generation, symbolic music generation, and audio processing. The results of this research are then implemented as tools for music production by development teams, and these tools are then sent to artists so that they can provide us with feedback that will then be used to orient our research and development. Um, we want to address a question very early in this talk because, as I said, we are working a lot with artists, and we want to advocate that we are not trying to use AI to replace artists. I will let Stefan go further with this.
Yeah, exactly. So as I uploaded DrumNet to archive, within a few days, lots of articles in the internet appeared with titles like "Sony is using AI to replace drummers," or "Sony is now our enemy," or "Will Sony replace human drummers?" And we also got a very nice input here. If he doesn't speed up during the solo, you'll know he's not a real drummer. We will look into that. But in general, we see that people are concerned with AI replacing artists, and we just wanted to point out that it's just not our goal to do this. We are focusing on creating AI-powered tools and AI-powered instruments, which will enable musicians instead of replacing them. So, like this tweet of François Chollet, who was the founder of Keras, is he says one of the worst take I hear constantly is technology is neutral, neither good nor evil, it's just a tool. The designer of a tech product, algorithms, interfaces, modulates who it will empower and who it won't. It alters prior power dynamics. And so as our goal is very different than just replacing artists, we want to create tools for them. We have also interfaces where you can interact with AI. So what we are actually doing is not replacing artists, but creating really cool tools which artists can then use and be hopefully more creative with them. So I will go now quickly over the evolution of music technology, just to provide some context in what it means that AI now enters the stage. We start with very primitive instruments we had available before Christ already. They are usually have a very they don't have a relative tonal system yet, so these instruments more or less stood for their own, and it was not so easy to play along together. We also see this in the notations we found from ancient times, but let's look at the early Europe notation, where we have no actually note length, we have no accidentals, because we didn't have actually the notion of different scales so much, and it was monophonic and quite simple music, which was notated here. And it really was just in the 17th century that complex and modern instruments emerged. And there is this very important work of Bach, Well-Tempered Clavier. And it was possible to write these different fugues in different keys, because it was this technical invention that you could temper or tune instruments in the well temperament, and from there it was then possible to play in different scales and also have modal phrases without making them sound odd. So a new technology led to a new kind of music. And let's go even further now in the modern times. Studio recording is really changed a lot again. We didn't have this separation of notation and performer anymore. You could really just play in some tracks, and it's immediately, and it is notated, and it's then standing on its own. So there were important names like Phil Spector, who tried to make this sound really good at the loudspeakers at the time. We have the Beatles, who became actually really world stars because it was possible that their music is distributed without them being present at the actual listener. And also Pink Floyd did a lot of new stuff, sound effects, special effects. They really created new music by playing around in the studio, and this was also quite a big milestone. So before, a bit earlier already, there was Pierre Schaeffer, who is taken as the godfather of sampling. He really, I play this video now quickly.
Pas grand chose à faire. C'est pour Babel et pour vous, François. A et B. B, François.
So Pierre Schaeffer basically realized that already recorded music can be taken and can be put in different contexts and can be reused in order to create even new artistic work. And this then, now we are at the Moog synthesizer. It was one of the first really complex electronic instruments, and it made it possible to play actually with timbre, with sound. It made it possible to also gain some unexpected results by just playing around with the parameters. You could suddenly obtain results you haven't expected, and this again drives creativity. So you had, the first time you had this notion of exploration, and you explore the space of possibilities which you didn't know before. And that's definitely a big step. And it also had a sequencer in there, so it was already another step towards loop-based music. So then there was this digital revolution with the Fairlight CMI. We know digital changed a lot in terms of data processing, and this is the Fairlight CMI was the first DAW, digital audio workstation available, and this was a predecessor of what we have available now. So we have now Logic and Cubase and also Ableton, and here it's really now possible to use musical objects and organize them into a arrangement, and to directly work with objects which sound on their own, to recombine them and to really sketch and construct your musical scene very nicely. And this also notion of having loops available and being able to loop very easily also led to new music and to loop-based music, electronic music, and trance and so on. And Ableton Live actually then designed an interface for this loop notion, and here it really is not anymore about a cursor temporarily going from left to right, but now you have just lots of different loops which can be recombined, and you don't the time goes basically over the loops and loops in itself. So that's now where we stand now, and then comes AI, and the question is, how will AI influence the way of how we make music, and at the same time then also how the music will sound we will make with AI. So when I say AI here, I mean the modern connotation, so like just deep learning and machine learning, and not the AI which was used before. And we see that it is actually a disruptive technology in many areas, but especially for being creative in music, it's not yet well established. If you would ask musicians now, they would not necessarily mean that AI is actually really necessary. So I found this tweet recently of Bob Sturm, who say, do we really need to involve AI in music? No, in the same way that we really don't need to involve pianos. Well, maybe it's not that simple. I definitely agree from a creative point of view. Currently, that's the state we are in. But we see already AI in so many different musical areas. We can use source separation for new kinds of remixing. We can see it in audio restoration, audio enhancement, for live DJing, and for recommender systems, of course. So we have already AI in many areas of music. And in the creative part, I think it will also be soon very pervasive, and we would not think about AI like single instruments anymore. AI would be just a technology, like electricity is a new form where you can build lots of different things out of it. So so this is why we now ask this question: how will AI change the way we make music, and what will be the sound of AI? Because we have now a new technology available, and we saw already that new technology allows for new possibilities, and then when you use them in a creative way, then you will obtain new results. Okay, Sera?
Yes, through the history of music technology, we have seen that innovations and new technologies bring in new music genres, new ways to compose music, and we can already wonder how it's going to be with AI. How will AI change our way of making music? We have, for now, identified 3 trends, what is already available on the market. Simplification, exploration, and interaction, that I will develop a bit further now. So, for example, by simplification, we mean higher level control. So this example of a very powerful drum synthesizer allowing you to control a large amount of parameters has actually kind of proved counter productive for some artists that get lost in the enormous amount of control they have. So by simplifying and controlling the sound on a higher level, maybe it will eventually be easier to design your sounds. It's the same phenomenon that happens with, for example, NVIDIA GoGAN, where you could have this photorealistic image after tens of hours of work, but now you can very, very easily get a draft from this application, just drawing a sketch, a segmentation map, and you have a very, very good rendering. Obviously, this simplification changes the way humans interact with the tools, and it allows for way more exploration. Since it's really simple to produce content, then you can produce much more content, and then you can explore through what you have produced and handpick the parts you like. So this can be done with example through latent spaces, choosing through proposals, or asking the AI for some recommendations. It's already in use in some tools available on the market. For example, here, Algonaut's Atlas, which is a sample library organizer. It allows you to represent all your sample in the latent space and then to create drum kits from one mouse click by selecting related drum sounds. So obviously this simplification and exploration will bring in new ways of interacting with the machine. The machine will not only be a machine, but also a support for your creative process. Hopefully it will increase your productivity, creativity, because we will be able to design agents with personalities. Hopefully too, it would introduce new ideas into the composer's mind, and it will make them able to compose with more diversity than they would have if they rely only on their own. So we hope that this way we can augment the artist and boost his creativity. Still, the question needs to be asked, what would be the sound of AI? For now, it's still very, very difficult to answer this question from the music, like the sound point of view. We can still argue that it will not be just a trend that will pass by. For example, this picture from Obvious that was sold $500,000 at an auction house in New York was generated with AI and computer vision. And the glitchy aspect of the picture is what made it successful, because it looks like AI. We still don't know if some similar phenomenon could happen in music, since musical artifacts are not perceived the same way as in image, but there are many other ways in which AI can shape a new genre or new ways of making music. This is what we're going to describe now. We are going to explain what we do towards, or how we envision AI augmented creativity, and we will try to stand from the artist's point of view rather than the scientist's point of view. So I will let Stefan explain you the new taxonomy we have for the control types, and present some tools.
Okay, so for the artists, it's definitely mainly interesting how to control the model, and that's why we try to take this stance now, and we look at it from this perspective. So we all know what's latent space exploration. Meanwhile, we have the latent space of any neural network, and we can explore. Then there is control through content, which is for conditional models, that they depend their output on what you input, and you can actually be quite creative with how you input and what you input as a conditioning input. Then there is control through refinement, which has a bit of this in-painting way of flavor. So you basically, as an artist, you work directly in the data space and you refine. You can sketch in there. You can maybe delete something and let it regenerate it. So that's control through refinement. Then there is also control through examples. The analogy is a bit like few-shot learning. You provide more than one example. You provide a small data set, can be very small, and then with this you restrict the latent space, or you restrict the model to a certain style you give it, and that's very interesting for musical applications, because musicians usually want to, or very often want, the model to create in their own style, and so that's definitely an interesting way to control a model. So as the first tool we want to introduce is the drumnet. Drumnet is I think I just played a video and then we can talk over it a bit.
I don't know why, but I'm feeling so sad.
Yeah, so that's basically the existing content, and we take now drumnet and we export this as audio. So drumnet works on audio, and it's a conditional model, so it listens to what you input, and from there it can then give you different proposals. So here it's about labeling what the input actually means, and from there, that's what you see. The star here is the latent space. It has still 16 dimensions. We are now working on reducing this dimensionality even further. And then it just gives you proposals. It generates you percussion tracks. And you can then import this in your musical scene again.
I don't know why, but I'm feeling so sad.
Yeah, and that's now another proposal.
I don't know why, but I'm feeling so sad.
Yeah, and the interesting thing in drumnet I feel is that it's a conditional model. You can input really a full song as a conditional input, but then you can still do latent space exploration, and for each point you choose in the latent space, the model will play in a different style along to the existing music. And that's an interesting point. And also we use directly audio, and we don't quantize whether input nor output. So we also can generate rhythms in these subtleties, which we are used to also as human drummers and players. Yeah, and then there's BaseNet. BaseNet is based on the same model. It's a gated autoencoder. And in this case, it's not only generating rhythms, but it's also generating pitched output. So basically it outputs F0 trajectories, and based on, again, audio input. So let's listen to an example.
Your love for me has just got to be real. Before you know the way I'm going to feel, I'm going to feel.
Okay, and also here for us it's important that it's not outputting MIDI, and it's not quantized also in the tonal area so much like MIDI is, and so that's also why you can hear some glides and other more natural aspects of the music. Okay.
I will carry on with Nonoto. So Nonoto is a tool that we have developed to interact with in painting models, symbolic in painting models. So it's an interactive score edition interface that can communicate with Ableton to help you create melodies. So I'll show you a brief video of how it works. So basically, you will start by inputting a chord sequence of your choice. This is on a particular model. By the way, Nonoto is model agnostic, so you could use any in-painting model. But for this one, you start with inputting a chord sequence. The model comes up with a melody, and each part of the melody you don't like, you can just change it by clicking on the blue boxes. This way you can refine your melody. This way we call it control through refinement, and connect this to Ableton Live so that you can play the melody with your favorite instruments. And basically, yes, this helps you create your own melodies. You could also fit it with your own initial melody and ask it to tweak it so that you come up with a new idea, maybe variations of your melody. We think it would be a very, very interesting tool for musicians to use, create new melodies, maybe even in a live context where you're playing and Nonoto is constantly playing a variating melody. Could be interesting. In the same fashion of in-painting models, we have a tool named Flow Machines Pro. This tool is about interactive generation of bass lines, chord sequences, and melody. It's based on Markov-Chain models, which allows us to introduce a new concept we called style palettes. It's basically that you can control Flow Machines Pro through examples. With a very restricted data set of pieces in your style, you could train Flow Machines to reproduce melodies, bass lines, and chord sequences that fit your style. We see this tool as a perfect tool to sketch a rough idea you might have and to use it as a basis for improvements and starting your track basically. Again, on the symbolic domain, we have a tool called Orchestra, which is automatic or assisted orchestration. So basically, you start with a piano score, like this one. And this transformer-based model is charged with finding a nice orchestration for it. So we think that these kind of applications are so cool for an artist that doesn't know, that hasn't learned how to write scores for an orchestra, but still wants its melody, his melody to be adapted for an orchestra. So this is a really great tool, and we've tried to make it as handy as possible, by example, by deploying a distant server so that you can use it through a Max4 Live plugin and that people can actually use it. In the sound domain, we also have developed some plugins, mainly on drums. This first one is called Planet Drums. It's based on a VAE model, so variational autoencoder model that features a latent space that you can explore to find a lot of kick drum sounds. I'll show you a brief video about how it works. So rather than browsing a sample library, we will try to synthesize our kick drum. So here we're now exploring the latent space. You can actually use control through input by encoding a sample you like. So it will basically encode it in the latent space and find its latent position, latent representation, and then by navigating around this point, you'll have variations. Well, I think by now you should have a pretty accurate idea of what it does. So once again, it's a tool we've made as an attempt to overcome the sample libraries, where you cannot do anything but browse with your down and up arrows, which is one of the less creative process one could think of. So yeah, we wanted to find a way to give you more control about the kicks you can generate. We have developed a second model very similar but based on GANs that I'll quickly demonstrate to you now. And last but not least, we have what we call the Automix project, which is a suite of 3 VST plugins, Profile EQ, which is a dynamic profile equalizer that is adapting automatically to your track so that it provides you with a very flat and neutral mix that you can work from then. A second one is called Resonance EQ, and its goal is basically to remove all these harsh frequencies and resonances in your mix that sound unpleasing. But actually, we've discovered there are also very creative ways to use it in reverse mode to emphasize the resonances. And the last plugin that is called cross-spectral matching, that is a spectral envelope matching algorithm, initially developed so that left and right channels of a stereo mix would sound more consistent, but we've also found that there are funny ways to use it for creative use. So all these tools are great proof of concepts individually, but we still wanted to know whether it's possible to create a track with them. So we've asked an artist to produce some content with the tools and to use as many tools as possible to see what would come out of this. And yeah, let's listen to the result. So, well, that's it. We were super happy to see that indeed we can produce actual music with our tools. The feedbacks from the artists were also obviously very, very interesting. In the beginning, he felt like the algorithm, the AI was trying to impose something on him, and that he had to fight against the AI to impose his own ideas. But in the end, he understood that there is a compromise to make, as you would make with this bass player, which is annoying you with that bass line he absolutely wants to play, and that in the end you find a way to make it fit into the song, and it sounds crazy good. So he had this times fighting with the machine from the artistic point of view, but also at some point he realized that there were some technical limitations that had to be overcome, and I will let Stefan talk a bit more about these limitations.
Yeah, so we're also facing technical limitations sometimes in our work. Like one which is very obvious, and most of those who train a machine learning model on music know about this, that we always have too little data available. And so it's not only about having data available, like even there are also questions about the legal situation, like what data can I actually use as training data for my model? Is it allowed to use copyrighted data or not? The answer is different depending on whom you ask. And also, the output should not be plagiarism, obviously. So it's also about, okay, what um, who owns the rights then of the output when he or she owned the right of the input. So this is one part which is interesting. But then let's say we have data available, like we have at Sony CSL, we have our own copyrighted material available. So then it's not always in the right format. So if we, for example, want to do conditional generation, we need the tracks separated, the instruments separated. For this, we use then, for example, source separation in order to get this data in the right format. Also for DrumNet and symbolic models, you could use transcription, or for sparsely conditioned generation, where you basically want to condition your output on single labels like pitch or any other label. You can basically use classifiers in order to label your data before, and then you can use this for conditional generation. So then there are also limitations, and this is very important sometimes in our work, that the limitations of DAWs. Artists actually want to remain in their own workflow, and so they actually ask you to create VST plugins or audio units. So they want to have plugins for their own DAW. And the problem here is that these plugins are extremely limited. Like DAWs do not really allow the plugins to do lots of different things. Where basically the VST audio unit specification is really buffer in, buffer out. And for AI applications, you actually would like to access the content of a session, like much more than just having these very short snippets. And you also want to then manipulate the content of a session usually. So this is actually something VSTs are not allowed to do in their general form. And it's definitely a big disadvantage in order to develop AI software. And then you would also maybe like to observe what the artist is currently doing, to observe the artist workflow, and also to learn from this in order to then maybe let the AI do some boring things for you. But this is obviously also not possible with VST plugins. So there are some solutions to it. There are DAWs which allow much more. For example, Reaper has its own scripting language, and you can here really access all different kinds of content, and you can also control the DAW itself. But Reaper is really not widely used under musicians, and that's why it's a bit still limited. You cannot use this for other DAWs, what you're doing there. Ableton Live is more widely used, and it provides an interface over MaxMSP, basically also to Python code. So this is definitely something interesting we are also using. But then it's still limited to Ableton Live, obviously. And so the best would be still if this can be done in a very in a VST or in another plugin. And for this, there is audio random access, ARA. This is very remarkable that Celemony, who developed Melodyne, it's their own, actually their only software they are developing, that they managed to actually design a specification which is now implemented also in the big digital audio workstations like Cubase and Logic. And this provides us with the possibility to access actually the content directly, the full of the whole track at once, but still it's limited to the track where the plugin sits upon. So we can still not read out all the regions of a whole session at once or so and modify them. And so that's why it would actually be really nice if there would be a much more unified spec and which gives you much more freedom actually for an API in DAWs. Like Reaper has its Rescript, it would be really nice if we could at one point have this available, and then we would be really able to interact with the session of digital audio workstations like we would like to do it with AI. And then there are different problems we are facing when we are really going into the design of AI tools for creative use. So one thing I want to point out is that we are actually coming from research. We are deep learning engineers, and there are actually some theoretical contradictions sometimes when it comes to creating creative AI. So in general, we want these tools to output some really novel material. We want to push the limits of what is possible currently, and actually machine learning has um, machine learning actually learns from existing data and it's learning to imitate. So it's actually not that interesting to just imitate what the training data was about. And that's kind of a contradiction when you want to really get creative with AI in music. And also that the output should be really characteristic, which means that a certain plugin, a certain tool should have a certain style, maybe a certain way it sounds, so that the artist can know that now I need this or that tool. But machine learning models also have just the characteristics of the data in the most theoretical sense. So one way out of this is that we can use the models differently than they've been actually intended, and we loosen a bit the scientific precision to ask for the actual error on exactly this data, but we kind of use models in a different way. For example, we could do out of domain input. So for DrumNet and also for BassNet, they're trained on specific data. And for example, DrumNet is trained on lots of data with 4/4 rhythm. And what we did here now, I will play this soon, is that we just input a different measure, a different meter, which was a 6/8 meter. And this led to a very humanized, still a 4/4 rhythm, but it worked still quite well, even though it was not exactly nice to listen to if we play everything at once, also the input. But if we remove the input, then we get actually quite a nice output. Let's just listen to this quickly. Yeah, yeah, and this input track also had some breakdown and tempo changes. It was not played in time with tick or metronome. So this also led to some very human output. Okay, I think I stop here because it would be a bit long, and go on with an example of BassNet, where BassNet is usually trained to on tonal input, and in this case we just tried to input actual percussion rhythms only, and which actually are not, none of them were actually pitched instruments, but still it was quite impressive what it gave us as an output. Let's listen to this. Okay, so that's this. And then what we can also do is we can really explore the limits of the latent space, where actually there was almost no training data available anymore. And we see what the model can then generate there. So this is a very short video where we see a bit of the sound where it starts, where the model starts then in the very outer areas of the latent space, starts to have a bit glitches and so on. But this, for some artists, is actually where it really becomes interesting. So let's listen to this. Yeah. So for creative use, you can always use this, sample this, and send it through other effects and make something out of it. So this was the out of normal parameters example. Then what you also can do is you can use the output of an existing model differently than intended. So for example, drumnet we know gives you all different kinds of rhythms for different kinds of percussion instruments. But in this example we will hear now is that the artist actually, a very talented artist, Don Healy, working with us since very recently, he used drumnet to basically generate all the rhythmic instruments in there, including synthesizers, and also in the end you will hear a melody which is generated by drumnet and then pitched by the artist. So everything here you hear is generated with drumnet, and I think one track also with bassnet. But yeah, I think it will show what I was talking about. Okay, let's listen to that. So now the melody. So the rhythm of this melody is generated by drumnet. And by the way, also the emphasis on this melody, so which note is emphasized and the velocity of each note is generated by drumnet, and then it's just pitched by the artist. Okay, so another way of using a model differently than intended is a transfer learning in a transfer learning fashion, where you use the latent space of a trained model and then use this latent space as input for a different model and or any creative application. So this was a very interesting output of a hackathon at the Izmir conference 2018. Yeah, where they used just a downbeat tracking network and a drum transcription network, and then use the latent space of these networks when how it reacts to music, and input this into a visualization tool, where they then made these bubbles rhythmically move in a rhythmic fashion. And such things can be done also for creating musical tools, and yeah, we're also exploring these areas. So yeah, what we wanted to stress here is actually something Suran wanted to say, no? Or should, no,
Yeah, it's no
I
problem.
I should go here still, I think.
Okay. Okay.
So what I was mentioning already before, that there is a certain tension between the conventional machine learning and then the artistic use. There is also a different approach we have to take when it comes to designing use cases for creative use of AI, because we as deep learning engineers are usually used to have the task before, and then we choose the appropriate model for solving the task. But for creative usage, we have lots of different models available, and then we can actually ask what they could do for us in a creative way. So in this case, it's kind of an iterative process that we can ask, okay, what could this model do for us? We train it, we design an interface for it, but then it might not be optimal. So then we can again change the model design and maybe change the data we train it on, and so in an iterative process, we can approach our tools we desired.
Well, obviously, researchers cannot consider all use cases that an artist would like to have with a certain tool. It would be quite complicated to try to predict and to imagine whatever can be done with the tool. This is why we think that at some point, getting the artist into the loop might be an interesting thing to do, especially since the machine learning researcher that wants to develop tools for creative use does more than just machine learning research. There are many decisions that intervene when you're trying to develop a tool, many decisions about the look and feel, because obviously the machine learning models out of the box are not usable. You have to package them for people who are not trained scientists. Uh, this poses questions like how to represent a latent space. The notion of a latent space could be quite obvious, or at least intuitive to a deep learning researcher, but it won't be to an artist. Is there a way that we find special features that we want to emphasize on? Um, uh, this would highly impact the personality of the model. As an example, here we have impact drums. So as I told you earlier, this is a GAN-based model. So to generate kick drum samples, you navigate the latent space. But here we have identified that the radius, like the norm of your vector, is actually very good information about the loudness of your sample. So we've extracted this information from the latent space and represented it on the side so that the artist would have a very explicit control over the loudness of the sample and the distortion of the sample. So this actually originated the name and the design of the plugin, and being as consistent as possible and as original, as innovative as possible is really a desirable feature for artists to want to use your tools. So we think this is the difference between research applied to music and music research. In music research, the researcher has to think further than the model, but also think a bit about the application and the creative use artists could make out of it. Obviously, artists want to be under control. And they want to have hands on the tools and to be able to tweak everything. Still, for many artists, autonomy is expected from an AI system. AI applications are expected to be instantly usable because they are intelligent. We have figured out that we need to make it clear to the artist that at some point some tools need to be learned, just as music instrument needed to be learned. You could not pretend to be a guitarist if you don't know how to tune your guitar, even though nobody asks you to know about the wave propagation equations so that you can play it. You just have to know the basics, the surface of what you're using. So this understanding brings you more latitude in the way you use it. Bringing the artist into the development cycle is obviously of great interest. It's super useful first for optimizing the look and feel of the plugins we develop, because the artist instantly identifies and try to imagine how we would use it. Sometimes we have to find ways to express some ML related notions like a latent space and to find a good representation for it on a plugin so that the artist would instantly understand what it's about. So it's very, very useful to have them by our sides when we're doing this. And also it's super useful for defining use cases, because sometimes your model can actually do way more than you think, given the fact that you give it to the right artist that has the great idea of what to do with it. Still, it's very, very hard to find this artist that will help you, because they need to be on the same page. It's really hard for artists to imagine to use AI in their music composition process, because first, there are not many examples out there for now that would clearly point out what AI is about. Maybe at least once they have understood why they would use AI, they still have to understand what it is in terms of limits, where AI starts and when it stops. What is an AI solvable task and what is something that AI has nothing to do with. Because once you've done this, you can communicate with the artist way easier. once the artist has the right mindset, you can enter a training phase with the artist where you can teach him how to uh, understand AI, how to manipulate a plugin that is powered by AI. And this is something we actually do so that the artist's feedback are more relevant to us and more useful to us. We can actually translate it into new specifications for new models. And also it helps us a lot because we are learning how to interpret this feedback from the artist. And this is really interesting to see what is good, what is not good in this or that model, and how we can change this. Um, so in the end, Stefan, I think we still have to answer this question: what would be the sound of AI?
Yeah, exactly. This question is still not answered, I think, and it's really not so easy to answer. But we definitely can say that there won't be a sound of AI like there is the sound of a Moog. Because, okay, Moog is an electricity-powered device, but in our case, AI is like the new electricity, like Andre Eng also proposes. So it basically comes from all directions into the music production process, and it comes more as an orchestra than as an instrument. And as a user, then you can be the conductor. You conduct all these tools. You have more this feeling also that you are conducting because you are not necessarily the interpreter anymore so much. But yeah, this is actually how it should feel and will hopefully feel as an artist to work with these tools in the future. So it really will have an impact on the human-computer interaction. And from there, we can then ask, okay, how will this new approach to music making and interaction really have sound? Like, will it lead to different music, to different sound? And I'm quite certain that we will have much more new genres. We will have novelties in sounds and styles and arrangements and melodies and things like this because you can really very quickly obtain and try new ideas and obtain quite um, elaborate results. So I'm sure that it will really lead to a new styles and new genres. And it will also lead to further democratization of music making. So the artist is now able to also work from the studio. There doesn't from his own flat. He doesn't need to be in the studio anymore. So, but there are still people who don't know so much how to express their creative ideas yet, and they would now also obtain some tools where they can really be creative. So I hope this will also broaden the access to music making, and I hope that it will in the future feel a bit more like playing an instrument again, because using DAWs nowadays is very much constructing a musical scene. It sometimes even feels a bit like work. We are actually quite far away from this feeling of being a performer and expressing our emotions and stuff like this. So I really hope that through this higher level approach of controlling these tools and the new way of which AI allows of human-computer interaction will enable us to have this this fun again of actually playing an instrument. So I want to conclude with a quote of Don Healy, who is now working with us as an artist, and also with a piece he sent me today where he involved a lot of our tools. He used flow machines for creating melody and chords. He used BassNet for creating the bass line, and he used also DrumNet for rhythms. And maybe you hear also this human character of DrumNet, where it really sometimes sounds like a human is playing it. And this is also something Don pointed out, that that electronic music might gain some humanized effect again from AI-powered tools.
We really hope you've enjoyed this piece. The talk is now over, and we'll be more than happy to answer some questions during the Q&A session. So
Okay.
we hope to see you later. Bye
So
bye.
see you later.